All right, let's take a look at Advent of Code 2019, day 3. The gravity assist was successful, and you're well on your way to the Venus refueling station. During the rushback on Earth, the fuel management system wasn't completely installed. So that's next on the priority list. Opening the front panel reveals a jumble of wires. Specifically, 2 wires are connected to a central port and extend outward on the grid. You trace the path each wire takes as it leaves the central port. 1 wire per line of text. Your puzzle input. All right. The wires twist and turn, but the 2 wires occasionally cross paths. To fix the circuit, you need to find the intersection point closest to the central port. Because the wires are on a grid, use the Manhattan distance for this measurement. Okay. I think I understand what's being asked here. Wires do not technically cross right at the central port where they both start. This point does not count. Okay. So we basically have to trace the wire and then see if anything intersects with the other wire. These wires cross at 2 locations marked X, but the lower left one is closer to the central port by Manhattan distance, 3 by 3. Got it. Here's some more examples. Distance is 159 and distance is 135. Okay. So let's take a look at the input. Wow. Okay, I think I got everything. It looks like the numbers, it looks like about 1,000 by 1,000, but we're going to use a hash set. That's the way I'm thinking of doing it, is just stick all the points for each of the wires in a hash set. And then we can just see if, which ones they have in common. And calculate the Manhattan distance. Or that should give us the values, right? So we have to go through the shenanigans here of adding another day. Here, 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 and here. We have to add this as a module. Okay, and now we have, oh, interesting. Oh, I got to save it first. There we go. We'll jump to the module. We'll put this in here. We've got to change all the $1s to 19. And change all the $2s to 03. And now we save it. There we go. So now we have day 3, unsolved, unsolved. It's just coming right out of here. All right, so parsing should be straightforward. Let's say wire 1 is a hash set of I64, I64. All right, these are just going to be the locations on in the matrix, or what is this called actually? It's a front panel. Inside the front panel, it's just going to be a matrix of spots, and we're going to read in both the lines and then parse them into wire 1 and wire 2 as 2 separate hash sets. This is going to be a little tricky because we have to walk our way through, starting at 0, 0, I assume. Did I read that? Starting from the central port. Yeah, so it's up to us how we want to define it, right? It's just a central port, and we'll call that 0, 0. So let lines equal to AOC lib read lines input day03.text. And I believe we can just dump out the line for lin. This line's 0 should just give us, oh, we have to import hash set. Yeah, so this is line 0, and then we also have line 1. Yeah. Oh, this one's over 1,000. Okay, it doesn't matter. All right, so now we just need to walk each line and insert it into the hash set. So we can say, we already have the hash set. So can I say parse line of 0, and give it a mutable reference to self wire 1. It should tell me that this function doesn't exist. And we don't need to return anything. And we just call this wire. So we're going to start at 0, 0. Let xy equals 0, 0. And we can say for something. So our instruction in lines split, comma. What we'll do is we'll split the instruction now. The instruction should be a string. We should be able to get the first value. Let direction is equal to inst 0. And let amount is equal to inst 1 dot dot parse usize. Expect can't parse inst. Like that, right? Type stir can't be indexed as an integer, right? I just want the character at location 0. So what does that give? This also gives us a stir. Consider borrowing here. I can do that. Oh, I have to clone it? I don't want to clone it. Well, let's just do stir here. Right? Can I do this now? This is still a stir. Can I do this? No. So strings can't either. Let's put reference to that. Okay. We're getting closer now. Direction. So direction is going to be match dir. And it's going to be up, down, left, and right. Right? That's what I saw. Yeah. Up, right, down, and left. Okay. And then the amount is just going to be the amount we go up, down, left, and right by. So we basically say for in 0 dot dot amount. Oh, we're going to have to do this for each one. Maybe what we do is make this return the deltas. So delta is -1 for x and 0 for y. And then we just make one loop. Down is 1, 0. Left is, oh no, up. Let's make it xy, right? We're doing xy instead of row column. So y is -1, y is 1, left is -1, 0, and right is 1, 0. Now we're going to say let dx dy equal that. Now we're going to say for underscore in 0 dot dot amount, and we're going to just walk our way along. We're going to ignore the first one, right? This goes as right 8, up 5. So right 8. So 1, 2, 3, 4, 5, 6, 7, 8. We've already done that guy. And now we just go up 5. 1, 2, 3, 4, 5. So the first one, and it doesn't really matter though, does it? So we can say wire dot insert xy. I was just trying to figure out, yeah, we should add it first. X plus equals dx, y plus equals dy, like that. Make them mutable. And that just inserts into the wire. Everything else is in valid direction. All right, so it was able to parse the line. We don't see it, but it didn't panic. And now we should be able to parse line 1, or index 1 into wire 2. We should be able to print out the size of each one. So let's do that really quickly. We can say self wire len and self wire 2 len. Okay, so we can see how many entries there are. So now I think we just walk along, or we could just do an intersection, right? With hash sets, you can intersect them. Don't need that anymore. Not going to need Ratatouille for a little while. Let's do hash set. And if we can intersect two hash sets, that gives us an intersection. And I think you can create a hash set, an array out of it, I guess, of entries that intersect. So let's try that. Let intersection equals self wire 1 dot inter with self wire 2. Do I have to put it as a reference? And then we can say intersection dot len. Oh, I got to do a collect. It's probably going to tell me I need to collect it into something. It's saying I can collect it into a vec. Uh, 13. So I should be able to actually just print them then, right? Oh, I have to display them. Oh, because they're all references to, there we go. So now, of all these, we just need to calculate the one with the smallest distance. It looks like it might be 207 here. Right? Because these are the locations where all the wires intersect. So I should be able to say let min dist equals intersection dot map xy. X dot abs plus y dot abs min. Right? Iter map. And it's an option. Unwrap. We're going to assume there is one. All right, so it's, 207. Let's see if that's the right answer, 207. Hey, that's the right answer. Okay. That's good. Let's check in with Clippy. Oh, okay. I'll fix that one later. We just finished git status, git add source, git commit -m 2019 day 3 part 1. Very good. 2019 day 3 part 2. It turns out this circuit is very timing sensitive. You actually need to minimize the signal delay. To do this, calculate the number of steps each wire takes to reach each intersection. Choose the intersection where the sum of both wires' steps is lowest. If a wire visits a position on the grid multiple times, use the steps value from the first time it visits that position when calculating the total value of a specific intersection. Calculate the number of steps each wire takes to reach each intersection. Oh boy. Choose the intersection where the sum of both wires' steps is lowest. So now we have to actually walk along the lines. So storing these as a hash set was not it was great for part 1, not so great for part 2. What we could do is just store the number of steps along with the XY coordinate. And then just calculate that, right? Because we know the number of steps. Why don't we do that? So we just extend this to usize. So each position now has a number of steps. And if it already has, that's not going to work, right? I'd want to make a hash map now that maps the position to a size. Yeah. Okay, let's do that. So that's going to be the new thing. The new magic is going to be a hash map, which maps this to a usize. We're going to have to figure out this part, but I think we can do that by creating a set of the values and doing that. So this changes to a hash map. And now what we'll do is at this location here, I'm going to say, but I want to insert it if it doesn't exist, right? Because we're going to use the shortest step, right? Because we're going to save the first time it visits that position. I think there's a way to do that in one step. And I think Clippy will tell me. Right, so now we'll just store the steps along with this. We're going to have to fix up part 2 because we can't intersect these guys. It contains key. Okay. Okay. What is this telling me here? There's an insert with a similar name with different arguments. Oh, for this guy. Okay, yeah. Not worried about that. Okay, so what we're going to do now is collect into a hash set. W1 : hash set I64 is equal to self wire 1 dot keys. Is keys already a hash set? No, it's a keys. So I can do a collect, right? Oh, and we have to pull hash set in. Okay, I can. And W2 is going to be wire 2. And then this just becomes wire 1 and wire 2. Oh, no, we can't. Copied. Yeah, there we go. There we go. I knew there's a way to do it. I just completely forgotten. So it's wire entry XY or insert steps. There we go. So now we should have in this intersection, we have a list of all the intersections and we can actually get all of the values that we need. So we should be able to actually just do this. Intersections is a vec of I64. And that's all we need. And then we can just say self intersections like that. And this should still give us the same out. That's no good. Oh, we have to copy them again. Okay, if we run this, do we still get 207? We do. And now we have to write part 2. let's do this first. Unfortunately, I had pushed that into part 1. Okay, so git status, git commit -am refactor code for part 2. Okay, and now we have the intersections. We just need to loop over them and get the smallest steps, right? What do we need to do? A plus 5, 5 plus 5 plus 2 by the first wire, and this by the second wire for a total of 40 steps. The top right intersection is better. Only takes 15. The second one, first wire takes 15, the second wire takes 15, so it's 30 steps. Okay. I wonder if I should do a test on this before I submit the answers. It feels like I should be testing it first, but let's write the code and then we can let's write a test. Let's write a test. That feels safer. Test fn test. This is the first example. Yeah, this was the first example, right? We have a wire that goes like this. Okay, so test. So wire 1 equals this. Oops. And let wire 2 equals this. Can I don't need to call parse, right? I can just construct it. Let mut AOC equals AOC 2019-03 default. All right, so we're able to create a new AOC object. I should be able to now set AOC wire 1 is equal to, no, I should be able to say parse line wire 1 and then AOC wire 1. Can I do that in my test? I can. And then I should be able to also do that with wire 2. Right? And then I should be able to run part 1, which gives us the intersection calculation. And returns an output that we can ignore. AOC part 1. Right? And now we have the intersections. And I should be able to run AOC part 2 is returning a string, a vec of string. So we can say let output is equal to AOC part 2, and it should be equal to whatever answer we're looking for here for, we got another train, wow. 30, we're looking for the string 30. Assert EQ 30 output of 0. And right now it's just returning unsolved. Okay, so now we should be able to actually test this to make sure that at least for this input, we're getting the right answer. And maybe I should do the other ones as well. Maybe I write a little test runner just that has these lines and I can pass them in. All right, 13. So what we want to do is loop over all of the intersections, get the steps, and find the minimum. I'm going to write it with a for loop first, and then we probably can make it functional. Int for, I don't want to say int. That feels like a keyword, doesn't it? Oh, let's do it. Let's do it. In self intersections. probably like this, so we don't consume it. What we're going to do is get the size, the length from each one. Wire 1 is equal to self wire 1 get int unwrap, and wire 2 is going to be that, and then we just need the sum. Let mut smallest is equal to, these are all u sizes, so we'll say u size max, right? And then we can just say smallest is equal to smallest min w1 w2. Is it just looking for how many steps? Let's use combined steps. Yeah, so we don't even need to save the location of the intersection. That should be a plus. And then this returns smallest. All right. We got 28. Off by 2, which means each wire is off by 1. Somebody hit the bell. That means our steps are off by 1. That means, yeah, so this has to have, took 1 step to get where it's going. That was that mistake. So I think it's working. This bit works. Can we make it better? I think we can. Let me put these 2 tests in first. I'm going to extract this into its own test. Like this. Fine. fn run wires. Sorry, wire 1. Yeah, wire 1 stir and wire 2 stir, and we're going to just return u size, which is the what this is, parsed into a u size. 0 parse. I should not have to tell it. Doesn't like something I did. What doesn't it like? So I should now be able to say run wires with this. Assert EQ 30 run wires of this and this. Unwrap. Okay, and now let's do the next set. Make this test 2. Put these 2 wires in here. Like that. And what's the output? Should be 610. Yeah, looks like that worked. Okay, so I think we have it. Do we really need to do the last test? I'll do the last test once we get the actual answer. So if I hit run now, it should just work. 21,196. Yay! That's the right answer, and just in time too, because I got to wrap up at 9. Okay, I'm going to put that last test in there. Just for fun. So we can do this. So like that. And then the answer is going to be 410. Like this. Test. Yeah, okay, so that third test passes as well. Okay, good. So that was pretty straightforward. We just saved all the locations of the wires. We're storing a lot of data. We're using a lot of memory, but whatever. There's probably a way to do this without consuming so much memory. Because then we're converting all the keys. We're copying every key into this hash set so that we can collect them together, intersect them, and then figure out the smallest distance. Oh, yeah, that was the other thing. I think we can change this now to just do it as a self-intersections map. Iter map. And we're getting an intersection, which is an XY location like that. And all we need to do is, oops, this dot min. Oh, and then output it. Option usize doesn't standard format display. Oh, right, unwrap. Here, and if we hit, oops, didn't mean to do that. Yeah, okay. So now if I hit run here, yeah, 21,196, that was it. Yep, right there. Okay, so that's the functional version of it. This is sort of a functional version of it. We did have to do some work ahead of time to get all the intersections, but that's fine. But you see it took almost no time at all to run. And this is in debug mode. So yeah, it's even faster in release mode. All right, let's commit these changes.